is all about sequences and series. It's only 2 lessons long, and a lot of it you can either use your calculator, Desmos on the, if you're taking the SOL, if you're taking SATs, etc., use your calculator, or just use the formula sheet, and you will have access to the formulas on your test. At the end of this lesson, you'll be able to identify a pattern found in a sequence, use a formula to find the nth term of a sequence, write a recursive formula for a sequence, write an explicit formula for a sequence, and find and identify and apply arithmetic and geometric sequences. Let's get started. First, you've got a packet there, and some of it is just writing down definitions so you know what we're talking about. A sequence is a set of numbers with a particular order or pattern. Each number is called a term. And by the way, when I get done going over this page, if you're watching the video, simply pause it if you need to finish filling in the blanks. Okay? So a sequence is simply a set of numbers with a particular order or pattern. A finite sequence is a sequence with a limited number of terms. You have 5 terms, 10 terms, you could have 1,000 terms, but it's limited. An infinite sequence is just what it sounds like. It is a sequence or a list of numbers that have a pattern or an order, and it's unlimited. It doesn't end. It keeps going on forever and ever and ever and ever. So the set of whole numbers, that's an infinite sequence. Now, term notation. The first term in a sequence is denoted as a sub 1. A doesn't mean anything. It's the very first term. It's a way of talking about the first term. Each subsequent term is denoted a sub n, where n is the term number in the sequence. So a sub 4, that's the 4th term in the sequence. Here's an example. Given 1, 5, 9, 13, 17, and then a bunch above, identify the following terms. A sub 1, well, that's 1. A sub 4, 1, 2, 3, 4, that's 13. A sub 9, oh, we don't have an a sub 9. But if I look at this, 1, 5, 9, 13, 17, I'm going up by 4s. So all I did is up here, I extended it. Okay, I extended my sequence, so I kept my pattern going up by 4s, and then I was able to figure out a sub 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's the 9th term. And then 12, 13, oops, sorry, 9, 10, 11, 12. And there's the 12th term. So that's all you're doing, okay? It's not hard. Okay, sequences as functions. Since each term value is paired with exactly one term number, a sequence is a function with the following properties. The domain is the set of term numbers. N, you've got your first term, second term, third term, etc. And the range is the set of actual values. In an infinite set, the domain is the set of natural numbers. Okay? Remember, it's just the domain that we can tell. We can't do the range because we don't know what the rule is. Now, recursive rules. A rule in which one or more previous terms are used to generate the next term. So a Fibonacci sequence, 0, 1, 1, 2, 3, 5, 8, 13, 21, 34. What am I talking about? I'm talking about this guy right here, this set of numbers. The way we find the next number, you are given that A1 is equal to 0 and A2 is equal to 1. A sub n is equal to A sub n minus 1 plus A sub n minus 2, which is, whoops, boom, what it says up here. So if we take a look at this, when we do A sub 3, we need A sub 2, which is 1, plus A sub n minus 2, and we get 1. A sub 4 is equal to 1 plus 1, which is 2. And then 2 plus 1 is 3. 2 plus 3 is 5. 3 plus 5 is 8. 5 plus 8 is 13, and so on. This is a recursive definition. In order to figure out what A sub 37 is, I need A sub 35 and A sub 36. Without those, I can't figure out what A sub 37 is. So recursive rule or recursive formula means I need to know the value of the previous term or terms. Now, here's another example to help you out. Okay, we have a sub 2. First off, it gives you a sub 1 is 14 and a sub n is the previous term plus 9 for any n greater than or equal to 2, which says this doesn't apply to a sub 1 because a sub 1 has to be given. So for a sub 2, I need a sub 1 plus 9, and that equals 23. So that's my second term. To find a sub 3, I need a sub 2, I add 9, and I get 32. Now for a sub 4, I need whatever a sub 3 was. Well, that's 32, and then I add 9, and I get 41. If I want a sub 5, I need to take a sub 4, which I calculated was 41, add 9, and I get 50. Okay? Now, pause the video and try this second one. You back? Let's try it. Did you put in the 6, subtract 5, and get 7? Okay, and don't forget it's 2 times 6. Did you take the 7, plug it in here, and get 9? Did you plug the 9 in and get 13? Plug the 9 in, or 13 in, and get 21? If you did, fantastic, great job. Those are recursive formulas, and those are examples. Let's go to the next page. Okay, here's 3 and 4. I'd like for you to try these. For these two, you are also finding the first 5 terms of each sequence. So pause the video and find those 5 terms for numbers 3 and number 4. Okay, are you back? Okay, you know a sub 1, and then you know what you have to do to get your next term. Were you successful? And it's okay to get fractions. Just leave them as fractions. Okay, what about number 4? Now notice number 4, in order to get a sub n, you need n minus 1 and n minus 2. You need the 2 previous terms. So this only applies when you get to 3. So when you give me the next 5 terms, you can give me term 3, 4, 5, 6, and 7. And there they are. Good? All right. Now, for numbers 5 and 6, it says to write a rule for each sequence, then give the next 3 terms. Well, let's first look at number 5. If I want to write a rule, I've got 4, 11, 32, 95. What I want to do is think about, what do I do to 4 to get 11? Then what do I do to 11 to get 32? What do I do to 32 to get 95? Can I multiply it by? No. What if I multiply 4 times 2? That would give me 8, and I would have to add 3. If I do 11 times 2, I get 22. Add 3, that's 25. That doesn't work. Okay, so I try something else. I say, what about 4 times 3? That's 12. Okay, if I subtract 1, I get 11. What if I do 11 times 3? That's 33. I subtract 1. Ooh, that's 32. Now, if I keep going, 32 times 3 is 96, minus 1 is 95, and I find out it works for 284. Now, I know a sub n is equal to 3 times a sub n minus 1, take away 1. And then I can use that to find my next 3 terms. With that, try figuring this one out. Pause the video and try it. Did you get that you take half of the previous term and then add 10? And then there are the answers down below. So far, so good? Great. Now we're going to look at explicit formulas. An explicit formula is a rule in which the nth term is defined as a function of n. Previous terms are unnecessary. That means if I want to know a sub 1278, all I need to know is that I want 1278. I don't need to know 1277th term. So notice my formula. In the formula, there's no a sub n minus 1 or a sub n plus 1. It's just based on n. So, and I don't have to give a sub 1, because a sub 1, I just plug the 1 in. I plug the 2 in, the 3 in, the 4 in, the 5 in. So now, don't forget order of operations, what's inside the parentheses. 1 minus 3 is negative 2 times 7 is negative 14. 2 minus 3 is negative 1 times 7 is negative 7. 3 minus 3 is 0, we get 0. 4 minus 3 is 1 times 7 is 7. 5 minus 3 times 7, 14. I've set this one up over here. Notice it's 1/3 to the 1 plus 1, which means 1/3 squared is 1/9. Go ahead and try the rest of these. Pause the video. Okay, now that you're back, did you successfully get all the way to 1/3 raised to the 5th power? Fantastic. Okay, you've got 9, 10, 11, and 12. Find the first 5 terms of each sequence. You're not asked to find the formula, just the terms. Go ahead and pause the video, and then when you start it again, I'll show you the answers. You're back. There's 9, 10, 11, and 12. Remember that for each one of these, like for number 9, you're simply doing a sub 1 is equal to negative 4 times 1 squared is negative 4. A sub 2 is equal to negative 4 times 2 squared. That's 4 times 4 is negative 16, and so on. Okay? You simply replace n with term number you want term value for. Okay? That's it. Pretty basic. Now, here you have to write a rule for each sequence, then give the next 3 terms. And don't get too crazy upset if it takes you longer. Some people will see patterns fast. Other people will take a little longer. Okay? Some of the patterns are easier to recognize than others. But try it. And just so that you know, you're looking at negative 7, negative 9. What do I do? What do I do to 1 to get negative 7? What do I do to 2 to get negative 9? What do I do to 3 to get negative 11? Think about it. Okay. Did you get negative 2n minus 5? And then there are the 3 terms. How about over here? Think about inputting 1 to get 3, 2 to get 6, 3 to get 11, 4 to get 18. What might you do? You could multiply, add, subtract. It's all a matter of finding patterns. Pause the video and think about a pattern that you might find for 14, 15, and 16. It requires thinking and this is nothing new. This is the idea of what a sequence is what's new. Finding a pattern to data is something you should have been doing for a long time. You're back? So how successful were you? Some of these were a little easier than others, were they not? Okay, I think number 16, while it might look crazy, 1, root 2, root 3, 2, root 5, you actually notice that it's just the square root of n. All right, now, what you have is you've got homework 1, intro to sequences. And again, don't get too caught up if you're struggling with coming up with the rule, because really a lot of what we're going to be focusing on is specifically arithmetic and geometric. But the idea of finding patterns in numbers, that is throughout, pervasive throughout mathematics. So, homework 1, that's something that you want to do the first 14 problems, only 1 through 14. When you get to 15, it starts working on partial sums of a sequence, which means it's a series. So only 1 through 14. Right?